Hey guys, here is the chapter 22 screencast for you guys that I said that I would record. If you guys would, make sure you guys have your notes out, pens, pencils, highlighters, everything else should be off your desk. Make sure that you guys are following along as I go through the slides in relation to section 1. Add anything, highlight star. Make sure that you guys really take really good notes. That way you guys are completely prepared for the tests that you guys are going to take on Schoology over Christmas break. So without further ado, chapter 22 focuses on the Enlightenment and the scientific revolution. So let's get started here. We're going to cover today section 1. So kind of one of the big questions in this unit is kind of what led these Enlightenment scientists and these philosophers and thinkers to question the old ideas. Similar to the movement that we saw with the Renaissance, where artists and writers and all these great minds started thinking and questioning old ideas. What led the scientists and thinkers during this time period to also start to question those Middle Age and Renaissance ideas and further the thinking and just really push themselves? So the main themes we're going to talk about fall under science and technology, power and authority. And then we'll talk a little bit about the revolution in section 3. I'll tie it in, but keep in mind that we will be skipping section 4, so do not take notes on that one. So section 1, the scientific revolution. So kind of the main idea in this section is around the mid 1500s, scientists are going to begin to question kind of these accepted beliefs and make new theories based on those beliefs with the foundation of new experiments, new thinking, new technologies. And it's this questioning that's going to lead to a lot of the scientific methods that you guys study today in your science classes. A lot of the development and kind of foundations that are built upon in your chemistry class, in your philosophy class, in your biology class, and so forth. So let's kind of set the scene here. So as you guys know, the last couple chapters we've talked about, from the 1300s to the 1600s was a great time of change for Europe. From the landscape to the monarchs to the explorers that you guys did your videos on for 19 and 20. The Renaissance is going to inspire this kind of sense of curiosity in people at this time. And it's not just going to be in the arts and the literature and in those explorers. It's going to kind of branch out into a lot of other different fields. Scholars are going to begin kind of questioning those ideas, questioning the teachings, questioning the writings, questioning a lot of what the church, put its kind of faith behind in its word and power, and saying that this is what it is and this is the truth. And scientists and scholars are going to start to think, okay, well, yeah, that's been accepted for hundreds of years. Why though? What's the foundation? Where's the truth behind it? What's fact? What's logic? How can we break that down? The Reformation, that was that wild kind of reforming and changing landscape of the church. That's going to prompt followers to challenge the ways of thinking not only of God, but also kind of life and what the church felt and what the church believed. If they're willing to reform that, how does that kind of look in terms of, the lens into life in general? So another revolution in European thought is going to kind of begin, thinking about science and the foundations of life. But the biggest thing for you guys to really know is that it's changing how the people view the physical world. But this is a very, very slow change. I'm talking hundreds of years. So you're going to have the first guy speak up, kind of make some claims, and people are going to doubt him. They're not really going to believe him. And then hundreds of years later, they're going to start to believe Newton, who you guys know. And then eventually all fields are going to experience that type of thinking, okay? But it's a slow change. It's something I really want us to really kind of wrap our heads around. Our history textbook is in layers. It's not just one chapter chronologically after the next. You guys have seen a lot of our chapters overlap and continue to build. This is the same thing going on here in this chapter. So let's kind of talk about the roots of modern science here. So before 1500, scholars are generally going to decide what's true or false based on kind of those ancient Greek teachings, those ancient Roman teachings, or the Bible. That was kind of the foundation for everything. So a few scholars are going to begin challenging those ideas of those ancient thinkers or the church, by very carefully observing nature for themselves, observing things in their own existence, okay? Once they start observing those things, they record them down. Then they're starting to see how things aren't quite matching up. They're not aligning quite right with these, ancient teachings that they've kind of believed. So the first kind of thought here is the medieval view. In the Middle Ages, scholars are going to believe that the Earth was this, center of the universe, right? It's this immovable object, and everything else kind of rotates around it. So the moon, the sun, the planets, all of them are going to move, circular paths around the Earth. And common sense is going to support that view. The sun appeared to be moving around the Earth. It rose in the morning and set in the evening. And to them, it made sense that the Earth was going to, in the same way, be the center of that. And that Earth-centered view of the universe was called the geocentric theory. So geocentric, geo, their geography, center of the universe. That's, wrap your head around that. That's what they thought. The Earth was at the center. And it's not going to be until years later that they realize that that's not quite the case. So this idea, though, however, is going to come from Aristotle. And it's very important that you guys know his name. Aristotle, Earth at the center of the universe here. He is going to kind of come up with this idea, but then another Greek astronomer, Ptolemy, is going to expand on that theory. And you're going to see that to be a lot of the case in this chapter is one guy speaks up, makes this great observation, and then it's more and more people, more and more kind of discoverers after them are going to continue to build on their theories. So Aristotle, Earth, center of the universe, makes this observation. Many years later, Ptolemy is going to expand on kind of that theory. And Christianity is taught that, God had deliberately placed, our Earth at the center of the universe. And kind of think about it that, that really supports what the church was teaching, that the Earth was the center. We are the center of everything. And that, it's a very special place, and that this, life unfolded around that. So the Earth is going to back up what Aristotle and Ptolemy are saying. However, it's going to kind of begin to change. This new way of thinking is going to come about to be in about the mid-1500s. A few scholars are going to publish works that are going to challenge that idea. And think about it, though, they're going against the church. So we're going to see kind of this, this headbutt effect going on here. All right? So it's going to replace these old assumptions with new theories. They're going to launch kind of a change in European thought that historians call the scientific revolution. Okay? This new way of thinking about the natural world. So scientific revolution definition, you guys need to know. Make sure you highlight it or star it in your notes. If you don't have it written down, make sure you jot down this definition. It's a new way of thinking about the natural world based upon careful observations and a willingness to question these accepted beliefs, okay? So scientific revolution is simply new way of thinking about the natural world with the foundations in observations and kind of this a willingness to accept or willingness to question accepted beliefs. All right. So these discoveries and circumstances led to this revolution and what kind of spread its impact. There's a couple things going on here, okay? Explorers, we know at this time, are traveling to new lands or traveling to new worlds: Africa, Asia, the Americas, all these places that are big major players. France, Spain, England are colonizing, right? They're inhabited by new people, new animals, okay? These new discoveries are going to open kind of Europeans up to this possibility that there's new truths to be found. There's new lands. The Earth's not flat as they once thought, it's round, actually, okay? We're not the only land here. There's other lands on this planet Earth. There's other people, there's other animals. What else is out there? There's got to be these other new truths, okay? We know that the invention of the printing press is going to help kind of spread these challenging ideas, whether they're old and new, okay? We saw that with the Renaissance. We saw that with the Reformation. It's the printing press that's going to continue to spread these ideas, all right? European exploration is going to kind of fuel this great deal of scientific research, especially in astronomy and mathematics, okay? These explorers, these navigators are going to need better instruments, better geographical measurements, okay? And scientists are going to begin looking closely at the world around them. And they're going to make these observations that I mentioned just a little bit ago that don't match up with these ancient beliefs, okay? They're going to reach the limit of kind of this classical world knowledge. They need to expand. They're growing beyond that. All right. So one of the biggest kind of things that they start to look at is the field of astronomy. Okay. Other fields are going through this style of thinking, but it's very easy to explain in terms of the field of astronomy. Okay. It's going to start when a small group of scholars are going to begin questioning that geocentric theory, that theory that Earth is at the center of the universe. Okay. And what comes out of this kind of challenging is Copernicus's heliocentric theory, all right? So that geocentric theory, that the Earth is at the center, is not going to accurately explain the movements of the sun, the moon, or the planets. Though it's backed by authority, aka the church, and common sense, a Polish astronomer, Nicholas Copernicus, is going to kind of be a little troubled by that. In the early 1500s, he's going to become interested in this old Greek idea that the sun stood at the center of the universe, okay? So it's not that he just came up with this on his own. He read about it somewhere. He's like, well, there was that theory. Let's look into this a little bit more. And after about 25 years, okay, 25 years, guys, he studied the movements of the planets and reasoned that the stars, the Earth, and the planets revolved around the sun, okay? Hence, heliocentric, sun at the center, okay? And his theory, though, still did not completely explain why the planets orbited the way they did. It was still him furthering this idea. And I want you guys to know that a lot of scholars and clergy are going to reject that theory because it contradicts simply religious belief. And if it contradicted religious belief, you're opening that door for people to question other teachings of the church. So, kind of in fear, Copernicus is not going to publish his findings until the last year of his the last year of his life. And he publishes it in a book, and he's actually given the final copy of his book on his deathbed. So while he was, very revolutionary and very, pushing kind of this new theory, his book is going to cause very little kind of interest at first. But over the next century and a half, so roughly, 15 years, other scientists are going to begin kind of building on those foundations that he laid. Those same foundations that he found from, that Greek philosopher. So it's always this continuous building. There's going to be a Danish astronomer that's going to record the movements of the planets for many years. He's going to kind of produce mountains and mountains of data upon data upon data based on his observations. And then he's going to leave it to his followers to kind of make mathematical sense of that. Enter scene Johann Kepler. Very, very brilliant mathematician, is going to kind of continue the work of that Danish astronomer. He's going to study the data and conclude kind of that there are these mathematical laws that kind of govern, the planetary motion here. He's going to show that the planets revolve around the sun in an elliptical orbit, okay, instead of circles, as previously thought. He's going to kind of support Copernicus's kind of observations, support that Danish astronomers kind of furthering of that observation, and have mathematic and data to kind of provide like proof and truth to that. Then we kind of enter the scene here with Galileo, which a lot of you have heard of before. He's an Italian scientist, and he's going to do a lot of his discoveries through the use of a telescope. And it's very important to know that he did not invent the telescope. He's going to build his own telescope based on a Dutch instrument that could kind of enlarge far off objects, okay? And he's going to study the heavens and kind of publish a small book where he publishes his observations. And some of his observations include that, Jupiter had 4 moons, the sun had dark spots, the Earth's moon had a rough kind of uneven surface, those craters. And he's going to shatter Aristotle's theory that the moon and stars are made of a pure kind of perfect substance. His observations, as well as his laws of motion, are going to also very clearly support those early theories of Copernicus, those theories that people doubted. However, Galileo is also going to run into some conflict with the church. His findings frightened both Catholic and Protestant leaders because his findings support Copernicus, which goes against everything the church kind of gave its, power to, put its power behind. It went against teaching and authority. And if people believe that the church can be wrong about it, they could question any other church teachings. And we know that the church, they're in a weak spot right now after the Reformation. They need to keep their followers and keep the faith alive. So the Catholic Church is going to kind of warn Galileo not to defend the ideas of Copernicus. And although Galileo is going to remain kind of publicly silent, he is going to continue his studies. He's going to publish his book that kind of presents both sides of, the theories here. But it's clearly, he's saying, I support the Copernican theory. Okay, I support that the sun's at the center. And the Pope's going to summon him to Rome to stand trial, as we've seen, time and time again. And kind of under, pressure of, threat of being tortured and, harmed, he's going to kind of sign this confession and agree that the ideas of Copernicus are false. This is going to kind of have like a dramatic effect on Galileo's rest of his life. He's not going to be a free man. He's going to live under house arrest. So even though he's kind of contained, his books and ideas, however, are going to spread all over Europe. We know with, the printing press, how quickly word and kind of teachings can spread with that use. From here, it kind of spreads into, teachings like that are also going to spread into science. So that, revolution in thinking that Copernicus and Kepler and Galileo began developing becomes this new approach to science called the scientific method, which you guys use in your science classes today when you guys do experiments. It's those logical procedure for gathering and testing ideas that begins with a problem or question arising from an observation. Okay? So your steps here are kind of, form a hypothesis, then test it in an experiment. And then your kind of final step is here, scientists analyze and interpret their data and reach a new conclusion. And the conclusion either confirms or disproves your hypothesis, right? Everything you guys do in your science classes. All right? So we have scientific method, however, did not kind of develop overnight, all right? Kind of the work of very two important thinkers helped to advance this new approach. You have Francis Bacon and Rene Descartes, okay? And these two scientists are going to really kind of set the tone for this, all right? So Bacon and Descartes. So Bacon, English statesman and writer, believed that by a better understanding of the world, scientists could generate practical knowledge that would improve people's lives, okay? His writings are going to kind of attack medieval scholars for relying too heavily on the conclusions of Aristotle and other thinkers. He's going to kind of really urge scientists to experiment and then draw conclusions, okay? Descartes, on the other hand, from France, is going to kind of develop analytical thinking, which is going to kind of combine that algebra and geometry together, provide a new tool for scientific research. He's going to believe that scientists need to reject old assumptions and teachings, rely on the mathematics and the logic that support them. He's going to believe that everything should be doubted until proved by reason. So Descartes is the guy that said, I think, therefore I am. So he really, the only thing he really knew for sure was the fact that he existed, okay? So modern scientific methods are based on the ideas of both Bacon and Descartes, okay? Both of their thinking goes into kind of your development of your science classes today. Scientists have shown that observation and experimentation together with kind of these laws that can be expressed mathematically can lead you kind of to this better understanding of the natural world. But it's really important that you combine the two together, that observation and experimentation. Enter Newton, looking at kind of the laws of gravity here. In about the mid-1600s, those same kind of accomplishments of Copernicus and Kepler and Galileo are also going to kind of look at shatter those old views of astronomy and physics. And English scientist Isaac Newton is going to help kind of bring together their breakthroughs under a single theory of motion. So kind of what's true for, astronomy can also kind of be applied here on Earth. So he's going to explain the laws of gravity here. So if you guys look at this chart, which was in your book, it breaks down kind of changing the idea. Old science said that scholars generally relied on ancient authorities, church teachings, common sense, reasoning to explain the physical world. New science is kind of where scholars begin to use observation, experimentation, and scientific reasoning to gather kind of the knowledge and draw conclusions about the physical world. Newton is going to kind of study mathematics and physics. It was certain that all physical objects were affected equally by the same forces. Okay, and it's this great discovery that the same force that ruled the motion of the planets and is also going to kind of rule them all matter on Earth and in space. It's this key idea that linked the motion in the heavens with the motion in Earth, and it was the law of universal gravitation. So every object in the universe attracts every other object. It's this degree of attraction depends on the mass of the object and the distance between them. Kind of like he would break it down that the universe was, like a giant clock, and that all the parts worked together perfectly in ways that could be expressed mathematically. He believed that God was the creator of this orderly universe, like the clockmaker who had set everything in motion. So as these scientists begin kind of having their own revolution, it's going to kind of spread into many other different fields. Okay, astronomers explored the secrets of the universe. Scientists began to kind of study the secrets of the natural world on Earth. And careful observation and the use of the scientific method eventually is going to become important in a lot of other fields. A couple of those fields are scientific instruments. As they kind of develop new tools and for like these observations, some of those tools are the microscope, the barometer, the thermometer. Medicine and the human body is also going to be kind of a scene for this new age thinking to come through. In the Middle Ages, European doctors accepted kind of the fact of the writings of ancient Greek physicians who basically wrote their teachings by dissecting animals and pigs. And, these doctors believe that what worked in animals and pigs worked in humans. They never dissected a human before until this time. So they started kind of dissecting and doing autopsies on human corpses. And they disproved a lot of these beliefs and assumptions. So new ways that the human body worked, they started being able to record and observe and make these new kind of advances in medicine. One of the biggest things to come out of this time period was also the first vaccination. Chemistry is also going to have a lot of kind of new advances and new thinking. Chemists during this time are going to challenge Aristotle's idea that the physical world only consisted of 4 elements: earth, air, fire, and water. They proposed that matter was made up of smaller primary particles that joined together in different ways. So it's this constant spreading of ideas into other fields, taking the foundations from one and applying it to others, questioning what you've always been taught to find that real truth. It's these notions of reason and order, which are going to spur so many other breakthroughs in science, are going to soon move to other fields of life. Philosophers and scholars across Europe are going to begin to kind of rethink these long-held beliefs about humans, about the human condition. And then we're going to see that kind of spread out to, very, very important rights and liberties of ordinary citizens. Just as you question teachings and experiments in the natural world, you're going to start questioning other things. These thinkers are going to help kind of usher in this movement that challenged age-old relationship between government and its people. We've seen through, the chapters that we've studied, thus far together, that the government and kind of the relationship between church and state, between state and its people, was always changing. It's always a new landscape. It's an ever-living document, and it changes as the need of the people change. So as they usher in this new kind of relationship, it's going to kind of change forever the political landscape in numerous societies. And that is where we're going to kind of go through when we get to section 2 in the Enlightenment in Europe, which we will talk about Wednesday. So what I want you guys to do for the rest of class is review this section if you're confused about anything. Make sure you have your notes out, and I want you to finish taking notes on sections 2 and 3. You'll also have tomorrow in class to work on that. And then Wednesday, I will be back with you guys, and I will lecture on 2 and 3 and answer any questions you guys have before we go into break. All right, thank you so much.